All right, a rectangular block of wood has a density of 345 kilograms per cubic meter and measures 85.2 centimeters by 64.2 centimeters by 20 centimeters, right? It floats in water with a large face down. That would be the face that measures this, right? So this would be the height of it, okay? What's its mass? What volume of water must it displace to float? How far up the 20 centimeter side does the water come so that the block displaces this much water? How much of the 20 centimeter sticks up above the water? Okay, so that's just subtraction. We can do that. Okay, this is pretty straightforward. This is a floating problem, right? Okay, so first thing is let's figure out the mass of the block. Mass of the block is going to be volume, density times volume, right? And that comes from density is mass divided by volume. Okay, so the density of the block is 345. And then the volume of the block is 0.852 by 0.642 by 0.20. Okay? And notice that this is kilograms per cubic meter. Those are all meters, right? So this will just be pure kilograms, right? So 345 times 0.852 times 0.642 times 0.2. So it has a mass of 37.741896 approximately kilograms, right? Okay, so let's see. What volume of water must it displace to float? Well, you'll float when you displace a volume equal to your own mass, right? So we're going to use the density formula again, right? Only volume in this time is going to be mass divided by density, right? So that's going to be our 37.74, etc., divided by, and then the water is 1,000. Okay, and this is kilograms divided by kilograms per cubic meter, right? So this unit will be cubic meters, right? So I divide that by 1,000, and I get that it would be 0.03774 cubic meters of water is what we have to displace, right? Okay, so now let's picture this, right? This is very hard to picture. We've got the water level here, right? And we've got this block. And this block is going to be in the water at some depth like this, right? Actually, will be less of it will be below the water than this, right? So this surface here measures, this is our, picture this, right? This is our 0.852. This is our 0.642. And this side is our 0.2, right? So we're trying to say how far up do we have to displace this much water, right? So the volume is 0.03774 cubic meters, and that's going to be 0.852 times 0.642 times, I'll call this H, okay, times H, which is how far up the side the water has to go to displace this, right? Okay, so we can do this. So we take this number, divide by 0.852, divide by 0.642, and the distance up the side is 0.069 meters, or 6.90 centimeters. Yeah, that's interesting, right? Okay, so how much sticks up above? Well, if it's 20 centimeters, right, 20 minus 6.9 would give us 13.1 centimeters, right? So really this side here is 13.1 centimeters. And then down below is 6.9 centimeters. So it floats with not much of it below the surface, right? All right, now, that's a lot of steps, right? You figure out the mass of the water, the mass of the block, which is then the mass of the water you have to displace. You figure out the volume, then you figure out how far up the side it goes, right? But let's think about this, right? What if the block had half the density of water? Does it make sense that half would be submerged? That makes sense, right? What if it had the same density as water? Well, it would float with all of it submerged, right? If it had the same density as the water, it would float with all of it submerged. That is, it would just float, right? It would just be neutrally buoyant, right? Okay. What if it had 3/4 of the density of water? Wouldn't it float with 3/4 of it submerged? It would, right? Right? You see that, right? What if it had 1/10 of the density of water? It would float with 1/10 of its dimension submerged. Yeah? Okay, so here's the hack. Okay, you ready for the hack? The hack is this, right? The density of the block of the object, right, over the density of the fluid equals the x submerged divided by x total. Let's just try this. Shall we try this? Okay, so literally for this, try 345 over 1,000 equals x over 20 centimeters. Just try it. Just try that. So 345 times 20 divided by 1,000. Holy cow, x is 6.9, right? So that will save you a lot of time. If you want to do that, you've got it, right? It's just a simple proportion. Okay. Remember that it's the amount below the water, right? The amount above the water you have to subtract and find that. Okay? All right. Good enough.